So here we are with double replacement. Now, for a double replacement, you're going to have a metal and a nonmetal, and another metal and nonmetal, and they're going to switch partners. So in this case, I have lead nitrate. So I've got lead, which is the metal, and nitrate, which is a nonmetal. So a positive ion and a negative ion. These guys are in aqueous, which means that they're in solution. There's little lead ions floating around in here, and there's little nitrate ions floating around in here. We're going to mix them with potassium iodide. Now, potassium is a metal, iodide is a nonmetal. So these are also aqueous, which means that they are dissolved, and the potassium ions are floating around in here, and the iodine ions are floating around in here separately. So we'll put our little lead nitrate out there, and I'm just going to pour this guy into there. And you can see that right now this is a clear solution, and this is a slightly yellowish colored solution, but very, very clear, no precipitate, no solid particles or anything in either of them. So these would be AQ, which you can see under the formula name. And that just means they're aqueous. It means that they are dissolved in water. So when I add them, ooh, that's fancy. So what we see here is this is opaque. And the reason why it's opaque is that there's actually a solid precipitate that has formed. You can see from the reaction that lead iodide, which has now formed and is the yellow stuff, is a solid. So we've got tiny little solid particles at the microscopic, at the molecular level right now that have just formed. And they're going to settle out. You can even see some that have stuck to the edge of the jar there. And over time they will all settle to the bottom, and we'll see that the potassium nitrate, which is still aqueous, so little potassium's floating around, little nitrate's floating around, will be clear. We'll leave that for now and come back to it a little bit later, but you can clearly see on the edges that we have a solid here. It's just in powder form because it just formed, and it's all atom to atom connecting right now, so very tiny little bits and pieces. Now, just before we move on, I wanted to update you. Speaking of leaving things and coming back to them, this is our magnesium oxide, which has been allowed to sit, and some of the oxygen has actually left the magnesium and entered the solution in hydroxide form. And so you can see that the pink color of the phenolphthalein is really, really bright. So definitely a confirmation that we had oxygen forming on the magnesium. It started right on the MgO, and as it started to dissolve, then it moved out into the fluid. Pretty.